Integrals is net change. Integrals, integration, what we've been using, uses as net change in anything. Okay, so we have two concepts. We have distance versus displacement. Okay, so you can see by, it's green on my paper, but not on yours. You can see by the path, right, from start to end. However long you walk is distance. Displacement isn't distance. Displacement is how far you are from beginning to end. Okay, so distance is how far you walk. So if I walk here to the door and then I walk back, if I want to know how far a distance I traveled, I would grab a ruler, measure it to the door, and double it, right? That's how far I walked. That's distance. If I want to know displacement, what would my displacement be? 0, because I'm right where I started. Okay? So that's the difference between the two. Okay? So kind of distance is how far you travel. Displacement's like the most efficient way, right? The most efficient way there. Like if you were to go get in your car, get in the bus, and go to East Campus, the distance and the displacement would be different because there's no possible way unless you had some sort of helicopter or airplane to draw a straight line, right? Because we got to go down, then cut across, and then go down, and then cut across, right? Because that's the way the roads are traveled, right? So that's distance. That's why we never really say displacement when we're driving, because nothing's a straight line. Okay. Um, so, um, so example: 2 steps forward, 1 step back. What's the total distance? Well, I took total of 3 steps, right? So the total steps taken are 3 steps. Okay. What's the total displacement? Well, if I took 2 steps forward and then I took 1 step back, I'm 1 step away from where I started. Okay. Okay. So, in terms of integrals, what we're doing today, this is how we're going to figure it out. So if they want just displacement, just the change in position, verbally we say that is integrate the rate of change over an interval. So if you see that, they won't use the word displacement a lot. They'll say the change in the rate of, or how much did the rate of change over time, right? Something like that. Then we're going to take the integral from beginning to end for v of t, velocity. Okay, this is kind of your, this is where you're going to live right here, this section right here, because this is going to tell you how to solve the problem. If they want distance traveled, okay, you integrate the speed over the interval. Remember, speed is just the absolute value of velocity. Okay, so if you're finding the area, or if you're finding the integral for speed, you're really just finding this. Okay. New position, this is the big one here. New position. New position, you start with your old position, and then you just add the change in position. Seems easy, right? Well, it is easy if you think of it in terms of that. But we're going to be thinking of it in terms of this. Okay? So when you think of change in position, you need to be thinking of this right here. That's what change in position is, right? Change in position. Okay? S of A means where was I at to begin, or where was I at before, right? A lot of the problems we see today are going to be problems like there's a tub of water. So there's water coming in through a faucet, and then there's a leak at the bottom. So water's coming out, right? So they want to know how much water is in the container at one time. Okay, well, how much water was there to begin with? That's my old position. Versus how much water is coming in minus how much water is going out, right? So then we would use an integral. Okay, that's mainly the kind of problems we're going to see today. This is review. The bottom is review from derivatives, when we did derivatives, okay? Because it might say, when does the object move left? When does it stop? When does it move right? So this table is in your notes before, but I just put it in there because we're going to be using it a lot, okay? So this stuff right here is just stuff we've covered before. Just reminders. Okay. Okay, so here we go. Let's look at problem number 1. This is a question we've done before. We've actually done this question before, or something very, very similar to it. I can't remember it was exactly, but very, very similar to it. Okay? Question A, I should say, not question B. Question A. Okay. When is the particle moving? Okay, so let's read the problem. Suppose we have a velocity of a particle moving along the x-axis by v of t. Time goes from 0 to 2. Okay? That's it. From 0 to 2, that's it. That's all. That's the interval there. When is the particle moving to the right? When is the particle moving to the left? And when does it stop? How do we do that? Question A we've had before. Might have had it on a test. How do we do question A? Don't worry about question B right now. Question B we'll do later. But question A, how do we figure out when the particle is moving right? How do we figure out when the particle is moving left? And how do we figure out when it stopped? You rush? Exactly. You look at the table right before it. Move to the right. Ooh, there's move to the right here. Move to the left. There's move to the left right here. Stop. There's stop right here. Right? It's when velocity is positive, it moves to the right. It's when velocity is negative, it moves to the left. And when velocity is 0, it stops. Okay? So we have velocity. It's right there. So we got to figure out when it equals 0, when it's positive, and when it's negative. Okay? So let's see. 6t squared minus 18t plus 12, that's velocity. Set it equal to 0. How do I solve that? Yep, factor. Start with a 6. T squared minus 3t plus 2. Then what do I do? How do I figure out what t is? There you go, yeah. Factor using, you can use the x method, whatever method you're more comfortable using. So they got to multiply to be 2 and add to be negative 3. So the numbers are going to be negative 2 and negative 1. Okay. So I'm going to get 2 answers. I'm going to get t equals 2 and t equals 1. So which answer is that? Is that red? Is that yellow? Or is that blue? Which answer is that? Blue. Okay. So we know it's stopped here. Good. All right. So how do we figure out when it moves left and moves right? How do we figure out when it moves left and when it moves right? We know one of them. Now we need to know left and right. Hmm? There you go. We use a number line. So we have +1, +2. And then how do we figure out where it's positive and where it's negative? How do we figure out where it's positive and where it is negative? Hmm? Exactly. So all of these are exactly the same. This is the same as this, is the same as this, is the same as this. They're all the same. They're just factored versions of each other. So plug one in, plug in numbers here, 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 and see if you get a positive or negative answer, right? I would personally rather plug it in here because it's a lot easier to do this than squaring it, multiply times 6. This question, this A, would be a non-calculator question because you guys have already had that. So make it easier on yourselves. Use that. Okay, so if I plug in 0, 0 here is a negative, 0 here is also a negative. Negative times a positive makes a positive. Okay, and then if I plug in 0.5, half, or 1.5, sorry, 1.5, 1.5. So if I plug in 1.5, I get a negative here. I get a positive here times a positive. So I have a positive times a negative times a positive, which would give me a negative. Plug in anything after 2. So if I plug in anything after 2, 3, I get a positive here, positive here, positive here, all positives. So it's going to be positive. Okay. So stopped is at t equals 1, t equals 2. Right is when it's positive. So that's going to be from, where would that be from? That's a good question. Where would that be from? Hmm? There you go. 0 to 1, not negative infinity to 1 and 2 to positive infinity, because the only goes from 0 to 2. Okay, and then left would be from 1 to 2. Done. We've done that before. Okay, we have done that before. That's not a new question, but I put it on there because you are going to see velocity, acceleration, position. You're going to see that a lot. Okay, so kind of to get you used to it. Okay. Okay. Part B now. Part B says displacement over the time interval. Displacement. I've seen that word before. Saw it here, and more importantly, I saw it here. Displacement. If I want to find displacement, this is how I do it. 0 to 2, or A to B, velocity. Okay, so let's set it up. From 0 to 2, and then V of t, because it's going to be V of t, right? dt. So that's the same as 0 to 2. 6t squared minus 18t plus 12 dt. Okay. You just take the integral of velocity to find displacement. Okay. Well, that's just a fundamental theorem question. So I got to find the antiderivative. So the antiderivative is going to be 6t to the third divided by 3 minus 18t squared divided by 2 plus 12t, and then I got to evaluate it from 2 to 0. Okay, so let me change these up. This is going to be 2. This is going to be 9. Okay. Plug in 2, plug in 0. What do you get? That's your answer. Okay. Simplify. So what do we get? 816 minus 36 plus 24. 0, 0, 0 minus 0. So we get negative 18 plus 24. Wait, negative 20 plus 24. So you get 4. Positive 4. Okay. So the displacement part was new, but after that was everything review. Okay, that was from last chapter. So the displacement part, that was new, but once you got to the integral, that should just be autopilot for you guys. Okay. Okay, so now part C. Part C says now not displacement. Now total position, or sorry, total distance traveled. Total distance traveled. Okay. Well, let's go see what we need for total distance. For total distance traveled, we need to find similar, right? Total distance traveled says A to B for speed. A to B, but speed now, not velocity. Well, speed and velocity are very similar. They're just absolute values of each other. Okay. All right, so let's go do that. From 0 to 2, v of t dt. So we get 0 to 2, absolute value of velocity, dt. Okay. Now this is a calculator question, so we can use our calculator for anything. Okay. So I'm going to use the calculator for this guy here because they said I could use it, so might as well use it. Okay. So let's get the calculator out. Take a little bit of time to load up my calculator. So you should know where the integral is because we've done that before. So try to find the integral. See if you can remember where to find the integral if you're finding an integral. See if you can remember it. If you can't, when my calculator loads up, I'll show you. But we've done that before. So you might remember it. Or hopefully remember it. Okay, so the integral is in math. 99.9% of the stuff we do, you're going to go to math, right? Unless you're just like multiplying numbers, right? Most of the stuff that we do in this class with integrals and derivatives, you're going to start out with math because that's where all that stuff is. And then you're going to go down into where it says right below deriv is int function integral. Okay. Then you get something like that. Okay. So we put in exactly what we want. We match exactly our notes, right? So we go 0, 2. Okay. Now here we need not just a function, but we need an absolute value of the function, right? We need an absolute value. So we need to go find absolute value, okay? Absolute value is also the bars, right? The bars, there's no button for the bars. For the absolute value bars on here, they're hidden. They're hidden under math. So if you go to math, Okay, I believe, let's see, let me do a little, I can't remember exactly where they're at. No. There they are. Go to number, you click over to number, NUM number, the very first one, ABS, that's absolute value. So when you hit that button, it'll take you back with the bars. Okay. If you get stuck, I'm recording this. You can watch it later on the video. Okay. So if you get stuck, don't worry. It's taped. You can go back and watch it on the video. That's exactly why I tape it. Because if you ever want to pause, like you wish you could pause me right now and say, wait, you can later on. Okay. So now we're going to put in our function. Okay. So the function starts out 6t squared. 6. Our variables are right next to the green alpha button. Right next to the green alpha button, it says X capital T theta N. We're going to use that button there. It's not going to be a T, but who cares? Squared. Squared is down here to the left. Down here on the left side, right above the log button. Squared. Okay, and then we have minus 18. X, or variable. And then we have plus 12. Okay, that's our function, and then it's dx, because we want to use whatever variable we're using for the independent, we want to also put it out there. Okay. We want to make it look like our paper. Once we do that, except for the x's and t's, except for the variable, okay, you're going to hit enter, and it'll also give you your answer. Positive 6. All right. Okay. All right, so let's go back to our notes. We'll come back to this. Don't worry. We will have plenty of time to mess with the calculator. Later on in later questions, we're going to need the calculator too. Okay. Okay, so last question in this one. Set up an integral. Okay, so they want us to solve it. They just want us to set it up. Set up an integral to find the particle's total distance. So they want us to answer the question we just answered before, right? They want us to answer the question we did right before. But instead of getting a number, they want us to set up an integral without using absolute value bars. So they want us to essentially find, here's the thing, they don't want us to find the answer because we know the answer, it's 6. But they want us to set up an integral, just like we did earlier, without absolute value bars to get 6. Okay. So let's think of absolute value. What does absolute value change? Or what does it do? What is its function? What does it do to things? Anytime we have a negative, it doesn't, it's like, I don't want negatives. I just want positives, right? So when we take away absolute value bars, we're going to have negatives, right? With absolute value bars, there are no negatives, right? So we're going to have some negatives maybe. Okay. Well, where is it negative and where is it positive? Where is the function negative and where is it positive? Have we done that already? Where is velocity negative and where is it positive? Have we done that already? We did that, right? So where is it negative? Where is velocity going to be negative? From 1 to 2, it's negative, right? That means from 0 to 1. So let's write this down. 0 to 1, it's positive. And then from, I'm going to leave a space there. 0, 1 to 2, it's negative. I'm putting a minus sign there because if it's negative, I'm going to have to subtract it, right? Because I didn't have to before because it was absolute value. But now, since it's not, I would have to subtract it. Okay? So from 0 to 1, if I want to find the abs, or not the abs, if I want to find from 0 to 1, if I want to find the distance traveled from 0 to 1, what would I do? If I want to find the distance traveled from 0 to 1, what would I do? If you're flipping to the first page, good. If you don't know if you don't know the answer and you're flipping to the first, that's what I would do. Flip to the first page. If I want to find total distance, right? If I want to find total distance of anything, what do I do? If I want to find total distance of anything, what do I do? If I want to find total distance of anything, what do I do? I really wish the word distance was up there. Oh, wait, it is up there. What do I do? What is that? An integral of speed, right? But what did the question say? The question said, I don't want positives and negatives. So how do I find, what do I do? I use an integral. That's it. An integral of, not speed, because speed is absolute value. The question said specifically, no absolute value. So what would I use instead? Come on, it's not that hard of a question. What would I use instead? Mm-hmm. Velocity, yes, velocity. I would use velocity. Okay? I would use speed, but they told me specifically no absolute value. So I have to use velocity then, because that's just what's left over after the absolute value bars. So you would have 6t squared, or cubed, squared, no, minus 18t plus 12 dt. That would be a positive number. And then you would have this guy over here, which is the same thing. It would be also a positive, but we have to subtract it since we discovered earlier it was actually negative. It was below, it was, velocity was negative there. And we would add them or subtract them, whatever you want to do, add them or subtract them together, and that's how we would get the same answer. If you were to put this in your calculator, you would get the same exact answer as we did earlier. It's just one is with the absolute value bars, one is without. Okay. All right. Okay, so number 3. So number 3 is a question. I can't remember what year, but it was a question off of, it was number 1 FRQ on the FRQ section. I can't remember what year it was, but I took it from there because I started to see a lot of these questions on there. A lot of these questions on there. Okay? So I took one. Every year they release the FRQs. Okay? All right. To make sure I have your focus up here, because if I don't have your focus up here, that gets me thinking this is way too easy. So next test is going to be a lot harder. Okay? So make sure I have your focus up here. I don't want to have to compete with phones, with whatever else is going on, okay? I want focus up here because this stuff is tricky enough. Okay? Okay, so number 3. The tide removes sand from Sandy Point Beach at a rate given by R. Okay. The next part, a pumping station adds sand to the beach at a rate modeled by S of T. Okay. Both R and T have units of cubic yards per hour, and T is measured for hours 0 to 6. At time 0, The beach contains 2,500 cubic yards of sand, and this is a total calculator question because this comes from number one. It was number one in one of the FRQs, and number one and number two on the FRQs are always on the AP test are always calculator. Okay, so anything on this test, question A, B, C, however far it goes, we can use calculator. Okay, so like I said, this is a popular question. There's three things happening. Let me draw it over here. Let's see. There are three things happening. You have the beach. You have stuff going in. You have stuff going out. And you have stuff that's already there. Okay? So the question, why you've heard, why bring sand to the beach? Well, they actually do bring sand to the beach because the tide pulls, right? The riptide pulls things in, sand, right? So sand is pulled from the beach. So every once in a while, they have to move more sand onto the beach so that there's enough sand, right? So the tide removes the sand at R. That's the rate. So if I want to know how fast it's coming out, how fast the sand is moving, taking sand away, I'm going to use R. Okay. Pumping station. So now they're putting sand onto the beach. If I want to know how fast their pumping station how fast they're moving sand onto the beach, I'm going to use S. And then they said at the beginning of this whole thing, they're going to do it for 6 hours, I'm guessing. Yeah, hours, 6 hours. At the very beginning, there's 2,500 cubic yards of sand already there. That's how much is there right now. Cubic yard this is 1 yard. So up one, so if I was to make a box that big, 3 by 3 by 3 by 3, it's a pretty big box. There's 2,500 of those. Okay. Okay. All right. So that's the question. That's the setup. Okay. So let me write this down. Actually, you know what? Let me write it down over here so we can see it better. So here we go. Beach, pumping into it, pumping out of it, already there. So 2,500 is already there. If I want to know about pumping onto it, I'm going to use S of T. If I want to know about removing sand, I want to know about R of T. Okay, so I'm trying to do all this setup before so we don't have to do it later. Because the better you do, better you prep yourself, the better you give yourself a visual, the easier these questions are going to be. Okay? All right, so now let's tackle letter A. Letter A. How much sand will the tide remove from the beach during the 6-hour period? How do we do this? Because I get a very common wrong answer. So how do I do this? How do I determine how much sand will be removed, taken away from the beach in the 6-hour period? Here's the common answer I get. Maybe it's the answer that comes in your head. Oh, well, let's see. Sand to the beach. Removing sand, right? It says removing sand. Okay. That's R of T. So after 6 hours, right? So why don't I plug in 6 to R, use my calculator, plug in 6, get an answer, boom, I'm done. That's the answer I get a lot. Like the first time we do this, I get about 90% of the people say that. But that's not right. Why is that not right? Why is that not right? Why if I plug in 6 to the removal equation, use my calculator, come up with an answer, boom, I'm done. Why would that not work? There's two reasons why it wouldn't work. What's one reason? Yeah.
Oh, I was going to say, do we want to find the distance?
That's one reason why, right? So if we want to find the distance, that's the total amount. What are we going to use? That's one reason why, right? This is not the amount. This is the rate, right? This is the rate, right? So if I plug in 6, that's not going to tell me anything about amount. It's going to tell me about the rate. That's one reason it doesn't work, right? So if I plug in 6 here, that's going to tell me the rate at hour 6. It's not going to tell me anything about what's already happened. I want to know, do I just care about hour 6 on this? No, I care about everything that's happened up until then, right? So plugging in 6 to R won't answer this question for me for two reasons, just like Sebastian just said. For one reason, because we want to find the total amount. That's an integral. Okay? Plugging it in is not an integral. The other reason why is if I plug in 6, that would just tell me at hour 6, the rate at hour 6. It wouldn't say anything about the hours before. Okay? That's why I can't plug in 6, but I will get that every time. And I guarantee you, I will still get that answer, even after that speech. I will still get that answer. Plug in 6. No, it's not plug in 6. Another reason why, if it's a calculator question, guys, they're not going to give you a calculator to just plug in numbers. They're not going to give you a calculator to plug in numbers. They give you a calculator to save time. They know you can plug in numbers. You've been doing it since 6th grade, right? Even though it has a sign in there, you guys can still do that. Okay? The reason they want you to do that is because bigger things, higher level things. Okay? So we need an integral, right? So let's set up an integral. Integral means total, and that's what that is. During this 6-hour period, that means total. So anytime we need a total, that means integral. Total means integral. Okay? All right, so let's set up an integral. From 0 to 6, that's going to accumulate. It's another way of saying an integral is an accumulation function because it accumulates everything from 0 to 6. Okay? Okay, so we got that. What are we accumulating though? So what are we going to integrate, I should say? What are we going to integrate that would give us the total amount of sand that is removed? What are we going to integrate? Which one of these says the one I want? The total amount of sand. Yeah, the first one, yeah. First one does. The rate, integrate the rate of change over the interval. That'll give me the displacement, the change in position, the total amount. That's what we want, right? Do we have the velocity function? Do we have the velocity function here? What is the velocity function? R of t. Oops, dt. That's all the work I need to see. Yes, sir, use your calculator. Go to your calculator, figure out what that is. Okay? Now, can you put this instead? Yeah, you can switch this. You can put this in here instead. That's okay. But R of t is the same thing. Okay, so that's okay as well. And it's a calculator question, so why not use the calculator? This is showing me exactly what you're using your calculator for. That's all I need to know. Okay, that's all I need to know. So let's go to the calculator. Now on your calculator, you're not going to put R of t because your calculator has no clue what R of t is. So you actually have to put in the function there. Okay, so here we go. integral (0 to 6). We're not going to put r of t here because the calculator has no clue what r of t is. So here we have to actually put it in. So r of t is 2 plus 5 sine, and then 4 pi variable divided by 25. I usually like to put parentheses even inside because I want the calculator to know, hey, I am multiplying before I divide. So insert, nope, delete, insert. Shouldn't matter, but I like to put, if I have within a like a division problem, because this is a division problem, I like to put the numerator, if there's more than one thing in there, 4 pi x, I like to put that in parentheses just so that I know my calculator is going to do the top first and then divide. I don't want it to divide first and then multiply. Okay. Okay. Enter. There we go. So we're going to round here. So let's round. We usually go about 3 spaces. If you go 3 places after the decimal, you're pretty safe. So 816. 816. 31.816. Okay. What's the measure? What's the unit of measure? What's the unit of measure going to be? What does this represent? Yeah, there you go. It's not a rate anymore. So we don't have to worry about per hour or whatever. We just have to, I have a bunch of sand that's been removed. How do I measure that sand? It's set in cubic yards. Yards cubed, cubic yards. Done. Okay. So that means throughout the entire period, how much sand has been taken in by the beach, by the water? 31.86 cubic yards, almost 32. Almost 32 of those cubes after 6 hours. So if I had a cube that goes up 3 feet, over 3 feet, and is 3 feet deep, so if I had a cube like this, pretty big cube, after 6 hours, the ocean has eaten up almost 32 of those cubes. That's a lot. It's a lot of sand. And that's just in 6 hours, right? So that's why they got to pump sand on there too. Okay. Okay, so I don't want to go on. We have about 5 minutes. The rest, B, C, D, I don't want to go too fast on these because these are, like I said, these are extremely important with what we're doing. So I don't want to go too fast because I think we could finish the next one, but I don't want to rush it. Okay. So, like I said, we're going to take probably tomorrow and Monday to finish these notes. And then maybe even Tuesday, I'm going to give you class time just to do some on your own because I want you guys to practice. Okay. So it's going to be a while, but just know on the horizon, hey, this is the last section. So we probably have a test. Test probably won't be for, let's see if we do that Tuesday, maybe the week after. So not next week, but the week after, probably test. Okay. Because if we take a few days on the notes, review for a few days, all of that stuff. Yeah. Okay. So tomorrow when you come in, First thing you're going to do, I'm going to have the bucket here. Grab, if you need one, grab one. Okay, grab one, especially for this section because all the questions are calculator. All right. Okay, so we'll continue tomorrow.